the closer the average is to the mean. Okay, so all the random variables you are collecting must follow a distribution first. Then this law of large numbers will happen. Now, what's the Monte Carlo method? I don't want you to give an exact definition of it, but you have to understand how it's used. For example, if at least you should know how pi was calculated in my class example, right? Right. Monte Carlo method, and what is quasi Monte Carlo method? Do you know the difference between them? Anyone can remember this? Quasi Monte Carlo. What's the difference between this and Monte Carlo? Please reply. If you don't respond, I will skip it to the next question. What's the difference between them? Nobody can remember this? Okay, let me skip. So what's the difference between true random number generator and pseudo random number generator? Can anyone answer? I think that's also a very easy question, so I think you probably may not want to answer it. And let me just skip. So what's the basic form of linear congruential generator? What it's like? This is like the last output plus something multiplied by another thing, then mod by the modulus. And the result will be the next output. So that's the basic form with A, C, and M, if you can remember. So here's the question. How can you generate a random number between 0 and 1 using the LCG? Because the random number you generated using LCG was a long integer. How can you generate a random number between 0 and 1? This is the question. Okay, somebody remember this? Nobody?
Divided by m.
Yes, divided by m. Yes, but if you notice this range, this pi is closed. It's open, but it's closed, which means 1 is possible to get 1. And in this case, you may not want to divide by m minus 1. So what are the problems of LCG? At least one. You should remember at least one problem of it. What was that?
It will repeat.
Repeat? The period?
The period.
I mean, it has a period. Yes, it has a period, but the period may be very large. When you properly select the parameters, you can get a very long period, which may be equal to 2 to the power of 64. That would be good enough. So what was the biggest problem of this generator? Anyone? Hyperplane, yes, the hyperplane. So you use LCG to generate the n tuples or vectors or points. These points will be mainly lying on some hyperplanes. Then suppose you already have a uniform distribution, or more clear, you have a random number generator that can use uniform distribution between 0 and 1 to generate the next random number. Then if you have this generator, how can you generate any distribution? Remember the key of it? This is called inversion method. So for every distribution you want to generate, you first plot its CDF. The CDF, the value of the CDF will always be between 0 and 1. Then you generate a number between 0 and 1. Then put this point at the y-axis. Then you plot the horizontal line. Then it finds corresponding x-axis. So it's called inversion method. Here are two questions. First is, what is GCS, Geographic Coordinate System? I don't want you to give an example, give a definition. But if I ask you, if I say this place is of this latitude and this longitude, am I using GCS or PCS? This is GCS. If I'm using I'm using latitude and longitude. And when you are using longitude and latitude, what's your assumption? You are assuming that the Earth is a spheroid. This is your assumption. So it's not flat. But when you are using the projected coordinate system, you are assuming that the Earth is flat. No, the Earth is not flat, but you are going to project the non-flat thing, non-flat Earth surface onto a flat sheet. So if I give you a coordinate system, you should be able to tell if it's GCS or PCS. And I'll emphasize that PCS is based on GCS. Now, what is UTM? Do you remember the way that they created UTM? Do you remember that how they modify, how they added a false easting to make every coordinate positive? And do you know which UTM zone we are in?
17.
17, yes. 17 or 18. Or 18. Because Albany is 18. Now, what options do you have for storing GIS data? We can use shapefile. We can use coverage, which is already extinct. We can use geodatabase. And there are some kinds of geodatabases, which you can check in the slides. Now, what is table join? What is table join? Can somebody summarize? So we have two tables. The result of the join, of table join, each row in the result table will consist of both attributes in both tables, all the attributes in both tables. But the way they are selecting the records was by the relationship of the two sets.
So we share the same key.
Same key.
Yeah.
Same field.
Field.
Yeah. For example, the ID.
You mean yes, based on the key. You're right. Good. So you based on the key, based on a certain key, and based on whether this key exists in each table, you decide whether this record should be selected in the final resulting table. Then what is spatial join? I don't want you to give the explanation, definition. But if I ask you, if I have a very simple feature or vector, and I have another vector, and I ask you to give me the union of these two features, maybe, then you will be able to select from those options. So which is the spatial join of these two features? So understand it, don't try to remember it. Don't try to recite it. Now, this is the big part. I want you to read the concepts in this file. But as I mentioned, this class is open book, so feel free to print it. And if you print it, it will be useful for you. It won't be a waste of paper. So I recommend you to print this glossary. But before you print it, make sure you already read it. You know where this file is, right? I already put, it's in the 5th lecture, methodology. Now, what is link node abstraction and what's link connector abstraction? I won't ask you the definition, what it is. But if I ask you to use the link node abstraction to represent a network, you should be able to do it. Or how do you use link connector abstraction to represent a network? Bless you. Now, what's the big O notation? If I give you an algorithm, a simple algorithm, you should be able to use big O notation to to represent or to represent its time complexity. Now, what's Dijkstra's algorithm? This was already done in your homework. All of you did very well. I want to mention, every time you select the next shortest path, and you are not selecting based on the distance from the node to the current tree, but the distance from the node to the starting node. So this is the key point. And for example, if I ask you to continue the current shortest path search, you should be able to do it. So I have an ongoing shortest path search. Then what's the next step, and what's the reason for that? Now, do you remember what the time complexity is of Dijkstra's algorithm? Can somebody remember? If n is representing the total number of nodes, then what's the simplest form of Dijkstra's algorithm? I mean, in the best situation, maybe best situation.
N cube.
What?
N cube.
N cubed.
Right. I don't.
No, it's not n cubed. It was n log n. Remember this. Using the best data structure, the time complexity for this is O, big O, then n log n. It's in the slides. Now, the next big topic is traffic assignment. What is traffic assignment? Traffic assignment means for every trip, you are going to find its path. That's easy. But what is static traffic assignment and what is dynamic traffic assignment? For these concepts, I try to explain clearly in my previous lecture, but I feel I didn't do very well. So I'm trying to do it again. So in the static traffic assignment, you assign the path to a trip. And the result of your assignment is that you have a trip starting at this location, and it uses this path, and it ends at another location. But this trip only has a start time and end time, which means between the start time and end time, this path is occupied by this trip. This is unrealistic, because a traveler will only, at any time point, the traveler will only exist in one link. So there is no way that this traveler can occupy the whole path for the whole trip time range. And that was called static traffic assignment. So if you can simulate at which time point, at every time point, that where this traveler is, then this becomes a dynamic traffic assignment.